Hello, this is the third part of the chapter 3.3, and we will talk how to find the areas and volumes using determinants. And theorem 9 in this chapter tell us that actually there is a really good applications of the determinants. If we have two vectors, which always we can complete those to have a parallelogram, we can find this parallelogram area by just calculating the absolute value of determinant. Also, if we have three vectors in three-dimensional space, we can complete them to get the parallelepiped, and its area will be can be found as the absolute value of determinant of the matrix composed from these three vectors. And that's usually the easiest way to calculate area and the volumes imaginable. So you probably remember how in multivariable calculus, you spend a lot of time calculating integrals to find areas of the parallelogram of parallelepipeds. Determinant makes your job much easier. For example, let's calculate the area of the parallelogram, which we has like 4 vertices are given here, and there is basically the image of this parallelogram. We would like to use theorem 9, but it's not just obvious right away how we can apply it, because the theorem 9 required 2 vectors, and vectors are usually start from origin, but here our parallelogram starts somewhere else. So first step in our analysis would be to actually shift our parallelogram that it would start in origin. It won't affect the area, so area should be the same. So we take our father's vertex here, -2, -2, and we will move it to the origin. And then we have to add 2 to the x and y coordinate of every single other vertices to basically introduce this shift. So we will have 4 new vertices, and one of them conveniently start at the origin. And the rest of them, you can see that we add 2 to each x and y coordinate of every single vertices. Instead of 0 and 3, we have 2 and 5. Instead of 4 and -1, we have 6 and 1, and so on and so forth. Okay, so now we actually can look at the edges of our parallelogram as a vector, A1 and A2. And since we know the vertices coordinates of both A1 and A2, we can make a matrix consisting of these 2 vectors. The first vector, A1, goes from the origin to the point 2, 5. So we are writing the column of this vector 2, 5 as our first row of the matrix. The second vector A2 goes from the origin to the second vertex, 6, 1. So we put it as a second column. So now if we want to find the area of the parallelogram formed by these 2 vectors, all we need to do is calculate the determinant, which happens to be negative, -28, but that's area, and area always positive. So we put the absolute value here, and I know it's maybe a little bit confusing for you because we use the square bracket, like straight brackets for the determinant, and now we put the straight bracket on the top of determinants, but that's an absolute value. Unfortunately, notation is the same. But okay, we can conclude that the area of our parallelogram is 28. And this is the absolutely easiest way to find the area of parallelogram. Okay, now go ahead by the end of the chapter and try to calculate the area. I'm sure you'll enjoy it.